Hello everyone. Today we're going to talk about K-maps, and the best way to learn K-maps is by actually doing K-maps. So you can see over here I have a two variable truth table, and I have exactly two minterms. So this minterm has not W, not X, and this minterm has W, not X. So what I'm going to do is I'm going to map out my outputs. And this is how you map it out. Your K-map always has as many little squares as you have lines. So you can see that I have 1, 2, 3, 4 lines. So I have 1, 2, 3, 4 squares. So the minterm itself gives me the coordinate where I'm going to put my 1. Right? So my first minterm that has a 1 is not W, not X. So I look which box has coordinate not W, not X. So these two boxes have horizontal coordinate not W. And these two boxes have vertical coordinate not X. So this box right here is the intersection of not W, not X. So now I'm going to go ahead and map out the rest of my minterms, right? I can go look at this one. This one has a 0, right? And the coordinate is not W, X. That would be this box, not W, X, right here. So I put a 0 here. Next one, I have W, not X. So that would be right here. So this one goes right here. And the last one is WX, that's a 0, and it goes in the last box. So you can see all I'm doing is I'm mapping out my outputs, right? And the coordinates are whatever's happening with the inputs. So how do you actually get this thing worked out, right? Well, what you do is you group them in groups of 2, groups of 4, groups of 8, and groups of 16, and of course groups of 1. So we're going to start with the group of 1. Well, the group of 1 is just the minterm itself. So if you have a group of 1, and if it doesn't make sense yet, it will make sense very soon. If you have a group of 1, then that's just the term that you have. So you're going to collect all the terms you're going to have, and you're going to add them up. So this is also a group of 1. So this one has the coordinates of A and not B. This one has the coordinates of not A and B, right? Not A, B. And this one has the coordinates of A horizontally and B vertically. Now, like I said, you can have groups of 2, and we just saw a group of 2. So when you have a group of 2, the coordinates that are itself and its opposite cancel out. So over here I have A, not B, and B. Well, not B and B, you can't have that. So it's just not A. So not B and B cancel out. Over here you have A, and once again not B and B. Those two cancel out. Now I have another group of 2, right? But this time it's not A and A that cancel out, because it's itself and its opposite, right? And not B stays, right? That would be the answer. And in this case, once again, it's not A and A that cancel out. Now, if you have a situation where everything cancels out, the answer is just 1. So there is a very nice roadmap on how to do this. So this is it. So construct the label for the K-map. I haven't told you how to construct the label yet, but it's very, very simple. And then place your 1s where you are supposed to have your 1s. Generally speaking, when you have a very large K-map, it's usually useful just to get your minterms that have 1, place all the 1s, and then put 0s everywhere. So I don't really like how this one says identify and group all isolated ones. Generally, I start grouping by hex. Hex is 16 if I have one. Octet, group of 8 if I have one. Then group of 4, then group of 2, and then group of 1. And of course, you are ORing together all the terms, right? So that's a plus to generate the solution. So let me show you how this works. So here is our nice K-map. So I have a minterm over here and over here. So this is not J, not K, equals 1. But first, I need to do a little something. I need to label my K-map. Now, you always start labeling your K-map with knots. So I'm going to grab J, and I'm going to put not J over here. And over here, I'm going to put J. So it's going to be not J, J. And on the other side, I'm going to put K, not K, and K. So you can see that it's already mapped out, right? I have not J, not K equals 1. So this one goes into this square. And this minterm, not J and K, goes into this square. So that's a group of 2. Not K and K, they cancel out. So the answer is not J. And guess what? This is it. We did it. That's all there is to it. In this case, because we only have a group of 2. Now let's look at the more interesting map. This time we have 3 variables. So the first question is, how do we name our squares? Because remember, we started with knots, right? But instead of 2 on this side, we have an 8. So what you do, you grab your first 2 variables. In this case, it's W and X. And you have not W, not X. And then you gradually take off the bar, take off the inverter from the top. But remember, guys, you take off the inverter from the second variable, not the first one. So first you're going to have WX, and then you have not W, not X, and then you're going to have not WX. Then you take off the inverter from W, and you get WX. Remember, you're going to have the term without the inverters. It's always going to be the third term, okay? And the last term is W not X. So when you look at it, guys, you will see that each term you have not W twice and W twice, not X twice, here and here, and X twice. Now the last one we have just Y, so we don't have to double up here. So this is not Y because knots go first and then Y. So now I'm going to map out my minterms, right? So this one is not W, not X, not Y, and it's a 1. So I'm going to put it right here. And I have 2 more. This one is W, not X, Y. So let's find this one. W not X is this row, and Y is right here. So I'm going to have a Y, 1 right here, and the previous one was right here. And the last one is WX not Y. So that one will be over here. So this is my, once again, not W, not X, not Y. Then all of these are zeros. Now this one is W not X, Y, W not X, Y, right here. And this one is WX not Y. So normally I just put in the ones and then I put in all the zeros. So what do I do now? Now I group them. Well, I don't actually have any groups here. I don't have a group of 2, I don't have a group of 4, I don't have a group of 8. All I have is ones. So all I'm doing is I'm taking the coordinate of just that one and I'm adding them up. So the final answer over here, now I can't type on a PowerPoint, you would have to type that up yourself. It's F equals to not W, not X, not Y, plus WX, not Y, plus W not XY. So I want to show you a few ways how you can see your groups of 8 and groups of 2 and groups of 4. So this is once again your group of 2. As you can see, the things that are itself and not itself cancel out. So C and not C cancel out, and the final answer is the remaining coordinate AB. Same deal over here. Now, here something interesting happens, right? You have not C, it doesn't cancel out. You have not A, it doesn't cancel out. What does cancel out is not B and B. It doesn't matter if it's standing next to the not A. We don't care about that. What we do care is that we have a B and not B. So they cancel out, and the final answer is just not A, not C. Same deal over here. Over here, you can see that it's not A and A that cancel out. So the answer is B and not C. Over here, once again, not A and A cancel out, so the answer is B and C. And so on. Now, here's the thing. Turns out that your K-map is not actually a rectangle. It's more like a circle. So what you need to do is you need to glue this edge and this edge together, because this is also a group of 2. Imagine if you have this edge on the top and this edge on the bottom glued together so that your rectangle makes a nice little cylinder. They will be right next to each other. And they are. So what you have is you have not C over here, not B, and then you have not A and A. And they cancel out because they're itself and not itself. Same deal over here. Now here's a nice group of 4. Now notice that the bigger your group, the nicer your solution is. Previously we had a group of 2 and our solution was not B, C. Now we have a group of 4 and our solution is just not C. Well, this one has one logic gate less than the previous one. Generally speaking, the bigger the group, the better. So let's take a look over here. What cancels out? Well, not C doesn't cancel out. But over here, we have B and not B, and not A and A. So all of those cancel out. So we just end up with not C as our final answer. Here's another group of 4. In this case, it's not C and C that cancel out, and also B and not B, and we're left with A. What a beautiful solution, since it's just an input. This is also a group of 4. Remember, these two edges are actually glued together, and this is a cylinder. Okay, so this is not C and C. They cancel out. And what also cancels out is not A and A. So the answer is not B. Once again, when everything cancels out, the answer is 1. And this is a nice group of 8. So let's take a look at another example. Once again, we have a 3-input truth table. And we have to label our K-map first. So we always start with knots. And I'm going to have G on and not G on the top. So over here, I'm going to have not G. And here, I'm going to have G. And then I'm going to go down. I will have not E, not F, not EF, EF. Remember, the third one down is always the one without inverters. And the last one is E, not F. So when I transfer my minterms, I'm just gonna do the ones, right? So I have not E, not F, G. Not E, not F, G. So it's this one, right? It's right here. The next one is not E, F, not G. So not E, F, that would be this row, not G, so it's this one. Next one I have E, not F, G. So E, not F, and on this side G, it's this one. And over here I have E, F, not G. So when you put them in and you put zeros everywhere else, you can start grouping them. So over here I have a nice group of 2. So you can see that not E and E are itself and not itself, so they cancel out. So from this group we're going to have F and not G right here, plus the other group. And the other group is G, obviously. And over here I have not E and E once again cancel out. So what I'm left with is not F. So my final answer is F, not G, plus not F, G. So what if we have a 4-variable one? That's a very, very, very large truth table. Guys, you do exactly the same thing. The only difference is that you now have 16 squares. That means it's going to be a 4x4. And that exact way we were naming our vertical column over here, you're going to name your horizontal column over here. So you always start with nots, not W, not X. Then you take off the bar from the second variable, not WX. Then the third one always has no bars, WX. And the last one has bar on the second variable, W, not X. So over here we have the same thing, not Y, not Z, not YZ. The third one always has no bars, YZ and Y not Z. So when we map this out, we're gonna once again transfer all the ones into the K-map. So first let's take a look at these 4, right? So this is my 1. I'm gonna have not W, not X, not YZ, not W, not X, not YZ. So it's this one. Now over here I have not W, not X, Y, not Z. So it's this one. The other 2 over here are zeros. By the way, they don't exactly go in order. So you can see, like on the PowerPoint, I have these little numbers, like which line goes where. But generally, that's a terrible way to do it because you'll have to memorize all of that stuff. It's much better just to go by the coordinates of your minterms. So let's take a look at the next 4 lines. So this is a minterm, and this is a minterm, and this is a minterm that has a 1. So I have not WX, not Y, not Z. Okay, not WX, somewhere over here. Not Y, not Z. So I'm right here. This is my 1. Next one, not WX, not YZ. So this one is the one right here. Next one is right here, not WX, YZ. So this one's right here. And the last one is a 0. Now once again, I usually just put in all the ones first, and then I put zeros everywhere else. Now this one, notice how it switches all the way down there, because notice the squares don't go in the order of your lines, so just put in all the ones first. So over here I have only one in this 4 lines. It's W not X, Y not Z. So W naught X, this line, and Y naught Z, that line. So they intersect right here. This is where I put my 1. And now I put the rest of my minterms. I have WX not Y not Z right here. Here's a 1. And then I have WXY not Z. That's right here. And of course WXYZ. That's right here. Okay. So let's group them together. Do I have a group of 4 or a group of 8? I don't, right? I don't even have a group of 4 because the group of 4 has to be adjacent to each other. This is not a group of 4, right? So what I do have is a bunch of groups of 2. So let's see how they go. So I have a group of 2 over here. 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 And then I have a group of 2 over here. Now, guys, there is a lot of overlap over here, and that's okay. Okay, so here's my K-map once again up close, and I'm going to go ahead and just color my groups of 2. So here's my group of 2. Now I'm going to use colored pens. Here's my another group of 2. Here's my third group of 2. Now the question I have now is what to do with these. Are they groups of 1s? No, they are not. If you can get a group of 2 with an overlap, it's always better than a group of 1. Just like group of 4 is always better than a group of 2, and a group of 8 is always better than a group of 4. It doesn't matter if you're going to have an overlap. Now, does that mean you want to overlap these two? Well, no, not really. They're already part of the group. But if you have a 1 that's not part of any group, it is adjacent to a 1 in another group, then an overlap is okay. So I'm going to have an overlap over here. And then I'm going to have an overlap over here. And my last one, which color didn't I have? Turquoise. Is going to be this group over here. So let's go ahead and write down that final answer. So I'm going to have F equals 2. So first I'm going to go ahead and take a group of 2 in black. So what I have is not W not X. And on this side I have not Y not Z, not YZ. So Z and not Z are there, so they cancel out, right? It's itself and not itself. So for this particular group, the expression is not W, X, not Y. And we're going to add this up. And now let's take a look at the blue group over here. Now, over on this side, you can see the vertical coordinate is always the same, not YZ. But the horizontal one, we have not W in both cases. And then we have X and not X. So X and not X cancels out. So this one is going to be not W, not Y, Z. Now let's take a look at the red group right here. So the coordinate over here is Y and Z. And over on this side, I have X. That's the same. And W and not W. They're itself and the opposite. So W and not W cancel out. So this one is just X, Y, Z. Now next one is the green one. Let's take a look. The vertical coordinates are the same. This is a vertical group, so this is Y not Z. Now let's see what's different on this side. Well, W's are the same, but X and not X are different. So this one is going to be W, Y, not Z. All right, we have to keep on going. We still have two groups, right? We have a purple group and we have a turquoise group. So let's take a look at the purple group. They are a vertical group, right? They're in the column Y, not Z. And let's see what cancels out. Well, not X is the same, but W and not W are different. So it's going to be not X, Y, not Z. And the last but not least is our turquoise group. Okay. So this one, I have Y, not Z. And on this side, I have X and W and not W. So W and not W cancel out, and I will have X, not Y, not Z. Now this is a terrible expression, especially if you're going to breadboard this, right? This is a terrible expression. But here's the deal. One thing that you know after you've done the K-map, that there is nothing else you can do with it, right? So that's worth something. Also, even to get to this point in Boolean algebra is going to take a while. So I want to show you a few more options of how you can have groups of 4 and groups of 2 and groups of 16 in this particular map. So remember, the top edge and the bottom edge can be glued together and it becomes a cylinder. So this is a group of 4. So is this and this. It can also be glued sideways. You can glue your left edge to your right edge. So all of these are groups of 4. Now, the K-map is a very, very strange concept, because when you have the corners like this is also a group of 4. So it's really hard to visualize this in terms of gluing it together, because it becomes this very, very strange shape. It's almost like a sphere, but so it is important to remember that the corners are also a group of 4. So if you have 4 corners, it's most definitely a group of 4. You can also have groups of 8. This is a perfectly good group of 8. And so is this one, right? Remember, you can glue it this way or that way. Doesn't matter. And of course, you can have a group of 16. In this particular case, it's going to come out to 1. So here's another lovely truth table. Once again, it's a 4-input 1. And this time we have to label our K-map. So the K-map, you're going to always start with nots. So this one's going to be not R, not S, not RS, RS, R, not S. And on this side, you're going to have these two. So it's going to be not T, not U, not TU, TU, T, not U. And then once again, you're going to transfer all of your minterms in there. So when you transfer your minterms, you're going to end up with this truth table. And you can see that you have groups of 4 in here. Now the groups of 4 overlap. But remember, that's okay. It's better to have an overlapping group of 4 than a group of 2. So I have one group of 4 over here and another group of 4 over here. So when you look at this group of 4, S and not S cancel out on this side, and T and not T cancel out on this side. So our final expression for this group of 4 is just not RU. Over here, we have exactly the same idea. So once again, R and not R cancel out. and U and not U cancel out. So this is just ST. Notice how nice it is. You have only two inputs in that term. That's beautiful. Then we have a group of two that goes sideways. And yes, it's okay that we have an overlap. That's fine. And another group of two that goes vertically on the edges. Okay, guys, that is all I wanted to say today. This video ended up being quite long, so make sure you pause it if you need to stop it and, you know, work out the problems by yourselves. So hopefully that was helpful.